Hello dear friends, I hope all of you are doing very well. In this tutorial I'm going to show you how to perform an accuracy assessment and how to compute a confusion matrix. In the last video we have seen how to calculate normalized difference vegetation index, which is NDVI, NDBI, NDWI and land surface temperature or LST, and in this video I'm going to perform an accuracy assessment. So let's check this out. First of all, I will show you the map for the year 2018. As my research area is Ukiah, I'm going to show you how to do accuracy assessment of Ukiah for the year 2018. And this is my map. If you remember, I've showed something like this from the last video. Here is the LST map. We don't need this LST map, rather we need the NDVI. This is the NDVI. As you can see, I didn't do anything to it. I didn't classify it according to different values, but I believe we don't need to classify it right now. Now, if you want to compute the area of a particular NDVI class, then you can't do it from here. That's because you didn't have any attribute table. In order to calculate the area for all the particular NDVI classes, we need to reclassify it. And this is what we are going to do here. So go to the search box. If you don't have the search box, press Ctrl F and then write reclassify and then press enter. And here you have reclassify spatial analyst. Click on it. And then you will have a box like this. Just drag and drop this NDVI file. And then you will see that ArcGIS have made some values, but we don't want to rely on those values, so we will classify on ourselves. Let's make the classes this number 6, and then we will input our break values as follows. This is my style. You can change it if you wish. 0.14, 0.18. So this is my break values. Let's click OK and OK again. Let's wait for a couple of seconds. And there we go. Here is the reclassified file. As you can see, in this file we can open attribute table, and from this table we can actually add field. Here it is. We can add field and we can basically calculate the area of all our NDVI classes that I have mentioned here. Water bodies, vegetation, built-up area, etc. We won't do anything with this box, or we won't compute the area right now, but we want to do an accuracy assessment. So the next step is to create some accuracy assessment points. In order to do that, let's click Arc Toolbox and then go to Spatial Analyst tool, then Segmentation and Classification. And then you will see create accuracy assessment points here. Click on it. And then you have input raster feature class. We have this reclass NDVI 19 as our feature class. Then output accuracy point, just to make sure that we don't lose this file, accuracy assessment for the year 2018. Save it. Classify is okay. For this purpose we will go for 300 stratified random accuracy assessment points. That's because we have 6 NDVI classes and it's recommended to have at least 50 to 75 accuracy assessment points. So 6 times 50 is 300, so I'm going for 300 accuracy assessment points. It actually depends on your NDVI classes. If you have 10 classes, then go for 500 points. Okay, this is how we actually calculate how many accuracy assessment points should we take. So here I'm going to click OK, and there you have it. You can see more than 300 accuracy assessment points, but these points are not that visible, so we are going to click on it, left click on it, and then we are going to change it to circle 1. Now we can see that it's way too visible. If you don't want to open Arc Toolbox and come to create accuracy assessment points, then you have another option. Just press Ctrl F and then you can just simply write create accuracy. If you write until then you'll get it. Then you have to come to this same point and it will bring you the same box as well. If you don't want to click on multiple Arc Toolbox points, just Control F and then write those things. It'll do the same thing for you. Okay. Now we have this accuracy assessment points. Let's check how many accuracy assessment points do we have. We have here about more than 313 points. Wow, that's a lot. Anyway, we will just make it short. We will just make it short, but before that we have something else to do, which is we need to convert it to a KML file or KMZ file. So let's search layer to KML, layer to KML, click enter, and then we have it, layer to KML. So we have to basically change or convert this layer file to a KML file in order to edit it on Google Earth Pro. So KMZ 2000, it's 18. Just saving it according to the name so that it doesn't get lost. And we can see that the layer has already been done. Now we can open the attribute table, place it here. That's perfectly fine. Then we should go to the editor and start editing. Okay, continue, minimize it and just place it here, and then we will move here, and here we have the newly made KML 2018 file. Let's open the file, and we have Google Earth Pro here. Okay, so these are the accuracy assessment points. This is the values from 2017. We don't need it. Double click once again to see all those points. Okay, so these are the accuracy assessment points for the year 2018, and now we will calculate. So here is ArcGIS, but before that we have to understand one thing, that this data is from 2018, so you need to click on the historical data set and then bring it back to 2018. My data is from February 2018, so here we go. This data is actually from 29th December 2017. Sometimes you see that if you want to put it on the exact date, for example, then 2018, sometimes we actually don't have a particular data, although we have for this year, but sometimes I did it for 10 years and I didn't find the exact data for a particular date. So yep, if you find it accurately, then you're lucky, but if you don't find it accurately, it doesn't matter, just work with the date that you find the closest one. Okay, here we go. So we have a lot of data here, more than 314. So here basically all this data starts with here 1 2 3 4 5 like this up to this 315 or 14, whatever. You can start by clicking on those figures as well, or directly from Google Earth Pro. It says that FID is 310. This is FID 310, and it says it's 1. In my classification, 1 is water body. If we zoom in, we can see that this is water body, so this is correct. And as I have started editing, now I can just click here and write 1. This is how accuracy assessment needs to be done, and you can make necessary adjustments to make it feel better. Yep, now you can see everything. Actually, this is how you need to do this accuracy assessment. Check for all those 314 points that we have. 313 points that we have here. So this is 308. If it is 308 and it says classified as 1, this is water body. If we have 1, then this is water body. This is water body as well. So this classification is correct, so I'm going to put 1 here as well. We have had only 2 points. We have 308 points left. This is 313. 4 is basically shrub and grassland. If we zoom in enough, then we see this is a road. Basically it should go under the section of built up area or barren land, as it says 4, or shrubland or grass. We are not taking it as a correct value, so we are going to put 313 as 3 because it's a built up area. and we have 312, which is 4. As you can see that this is grass and this is shrub and grassland, so we are going to take it as a yes. So we are going to write 312, 4. Now you have to fill up all those 310 points like that. You need to change the ground truth, and this is how you will do the accuracy assessment here. This is kind of boring, very boring, guys, but you need to be very patient. You may feel dizzy as well while doing it. That's because that's a lot of points, but be patient and let me do it as well. I will feel dizzy, I'm quite sure. See you after I do all of these accuracy assessments. Okay, so now after a couple of hours I have completed this table, and now we don't have any more -1 values, I believe. So now what we should do, we will maximize our ArcGIS profile, and then we can save those edits, and then, sorry, not this one, and then we should stop editing, and then we can press Arc Toolbox or Ctrl F, whatever it is. Let's try with Ctrl F this time. That's because the compute confusion matrix is just here. So let's try with Ctrl F. Here we should try confusion matrix, and if we click it just the same, we have here confusion matrix. Now we have all those datas here. Now this is very important. Focus here, just write confusion matrix 2018, and don't forget to give an extension .dbf. If you don't put this .dbf, then it will not be successful. So now as we have this .dbf extension, it will work, and we will have our confusion matrix. As you can see, compute confusion matrix is done, and there we have it, this confusion matrix here. Let's open it. And now this is our confusion matrix here. As we can see, we have kappa of 0.8, which is quite good. So this is how you can compute the confusion matrix and perform an accuracy assessment. If you find this video useful, give it a like and subscribe to this channel. Thank you.